So hello students, as part of our current affairs for the grand test, we are covering science and technology portion. We have 5 most important articles from the science and technology. So the first article is related to small satellite launch vehicle. Recently, ISRO has launched third developmental flight of small satellite launch vehicle from the Satish Dhawan Space Center in Sriharikota. Now, first of all, what is this developmental flight? There are two different kinds of flight. Whenever some kind of a new thing has been developed by ISRO, they have two options. Either to make some experiments when they are developing something, that R&D requires some new changes to be made in that module. If they are making a satellite or launch vehicle or anything. So in this stage, if they are sending that, if they are using it, then it is called developmental flight. But once something has been developed completely, now they are officially using it, then it is not called developmental flight, rather it is called operational flight. So as far as small satellite launch vehicle is concerned, we are in the developmental stage. We are still developing it. It is not yet completely done. Clear? Now, this topic is important as we need to know what is this small satellite launch vehicle, in short SSLV, and what is a launch vehicle specifically. It becomes highly important for prelims as well as mains because science and tech portion includes awareness in the field of space. Now, first of all, please understand what is a launch vehicle. Now, just like you guys travel from one place to another place, to travel you need a vehicle, just like a bus, car, bike or anything. Similarly, if you want to travel from Earth to any other part of the space, then what you require is a vehicle, and that vehicle is the launch vehicle. In simple terms, you can call it a rocket. A rocket or a launch vehicle is going to send something. Now, in this terms, we can say we are sending, let's say, a satellite. We want to send a satellite, or maybe we want to send multiple satellites, or in case we want to send human beings to the space. To send, we require a launch vehicle or a rocket. Now these launch vehicles, they look like this, somewhat like this. Now if you have a satellite, that satellite will be put over here. But the remaining part is the part of vehicle, which is also called the propulsion system. When you listen to this word propulsion system, simply what it means is a system which will allow this particular rocket to move. So it is kind of an engine. Now in bikes you have one engine which you use to move that bike from one place to another. In these rockets or these launch vehicles, you will have multiple engines and you will see multiple stages. Let's say this is stage 1, stage 2 and this stage 3. What will happen is that I'm saying these are different engines all together. In our bike, there is one engine in which there is a fuel called petrol. Similarly, here in the stage 1, you will have a different fuel. You will have a different oxidizer. In the stage, once you use this fuel, let's say you are using some fuel. In this stage 1, that fuel will be burnt and this particular launch vehicle will move ahead in the space. Once the fuel is completely burnt, completely exhausted, what will happen? This part of the rocket will fall down on the earth and only this remaining part, it will move ahead. And to move ahead, obviously one engine is required, one fuel is required, and here they will make use of this second stage. So here there will be a different fuel and it will burn. Once it is completely exhausted, this part will also fall back on earth and this part will start working. And again, the third part will be used. This is how we send satellites or human beings in the space. And for that, there are multiple stages in the launch vehicle. Clear? So this is the launch vehicle. Now, if we move ahead, what is a small satellite launch vehicle? Please understand, normally we have different kinds of launch vehicles. You must have heard about PSLV. You must have heard about GSLV. These are very famous launch vehicles which India has and many other countries have. Now these are big and larger launch vehicles. The GSLV is larger even than the PSLV. And usually what happens whenever ISRO makes use of these launch vehicles, ISRO does not send only one single satellite. Rather, they send multiple satellites. Let's say they are using PSLV. What they will do? They will put at least 50 satellites in the same PSLV and then launch it. Why? Because the cost of PSLV is very high. They think that we need to put at least 50, 60, then it is cost effective. You can think about it similar to our passenger vehicles, just like the auto rickshaw. Sometimes what they do, they say that at least there should be 6 people, only then we will send our vehicle, otherwise we will not. The similar thing is done by ISRO also in case of PSLV or GSLV. But nowadays ISRO is thinking, if we can send one launch vehicle, if we can use one launch vehicle to send even one small satellite also, then it will be really good, because nowadays the space market is emerging, it is becoming larger. Many countries, many businessmen are coming to ISRO saying that we want to send our satellite, and what ISRO says, you have to wait for next 2-3 months, we are working on a PSLV. But if you have a system in which you can build the system in 5-6 days and you can send that one single satellite also, that too in a cost effective manner, isn't it good? It is good. So that's why we have built, or we are building, small satellite launch vehicle. So just like PSLV, GSLV, this is also a launch vehicle, but a very smaller one. And the key difference lies in its working. Please understand, it can carry weight up to 500 kilograms only. It is very small. If you look at the PSLV, GSLV, they can carry way more than this. Some launch vehicle will have capacity to carry 5,000 kilograms of weight. But here the capacity is limited and we are going to send only small satellites here. This important thing is that it can have multiple things available in it. First thing, it is having 3-stage solid propulsion system. Now, what does this mean? It simply means, I told you about the stages. It has 3 stages. And in these 3 stages, the fuel that will be used is a solid fuel. Normally, we have different kinds of fuels. One of the fuel could be let's say in your bike, you have petrol. It's a liquid fuel. But there can be solid fuel also. For example, you can think about a gunpowder. Gunpowder is in solid form, but it can burn. So similarly, there are some solid fuels. And in all the 3 stages, we are using solid fuel. Solid fuel is considered to be relatively better than liquid fuel because it burns in one go. What happens with the liquid is that if you are burning it, if you want to stop the process of burning, you can stop it. But in case of solid fuel, you can't stop it. Once you started burning it, it will completely burn. And it is very easy to store also. Handling a liquid fuel is bit complicated, bit difficult. But solid fuel, it is in the solid form, directly you can keep somewhere. So this is a good thing about solid fuel, and that's why we are using it in the SSLV or small satellite launch vehicle. Second, it has velocity trimming module. What does this mean? It is going to trim the velocity. Velocity means the speed, simply the speed of this particular launch vehicle. Usually what happens is that when you're sending a launch vehicle and you want to send it to a particular location, let's say on this location we want to send it, but sometimes it does not go precisely on this location. Instead of this, it will go to this location or this or this. So the precision is not there. So in this SSLV, we have velocity trimming module. It will control the velocity or the speed of this launch vehicle in a very precise manner. It will control that trajectory also. And this will ensure that your satellite reaches to the exact location where you want to send it. So velocity trimming module will help you in the precision, exact location where you want to send it, it will send. Very important, this point is very important. Now, you have quick turnaround time. What does it mean? If you are building a launch vehicle, normally for PSLV or GSLV, you at least require time period of 70 days. That means more than 2 months. And you at least require 60 people, which includes scientists, engineers, etc. But if you're building SSLV, you do not require these many resources. Instead of 70 days, you will do this task in 6 days or 7 days only. Instead of 60 people, you only need 6 people. That means, you see, the resources are very less. You can do it in very less time period. The assembly and all this will be done in a very less time period. That's why we are saying SSLV is very good. As far as infrastructure is concerned, you will require very minimal infrastructure, which is also a good thing. So if infrastructure is less, that means the cost of the whole production process will be less. So overall we are saying this is very good for the space sector. Especially ISRO is thinking about commercialization. Earlier ISRO used to make satellites or send satellites only for Indian government, but now they are thinking about commercializing. That means they will earn money from sending satellites of different countries. So this is a good chance for ISRO. So SSLV is very important, but we are in the developmental stage as we said. Clear? Good. Now the next article is related to dual use goods. We need to know what are dual use goods, what are dual use technologies, what does this term exactly mean and why it is in use. Recently what happened is that US government alerted, gave some warning to Indian government and Indian companies. They said that some of the Indian companies are selling dual use goods and dual use technologies to Russian companies. And because Russia and Ukraine are at war, and because America is against Russia to some extent, they are putting sanction against Russia. So here, if Indian companies are selling dual use goods to Russia or Russian companies, Americans are not very happy. So that's why they have warned us. And even Indian government has said that we are going to conduct some inquiry and check if this is really happening. So we need to know what are these dual use goods, important for prelims specifically. Dual use goods or dual use technologies, these are nothing but goods or technologies which can be used for two different purposes. One purpose is the civilian purpose, and another purpose is the military purpose. Now let me give you an example. Let's say if I take the example of nuclear technology. See, when I'm using the word good, you can think about a product. So when I'm thinking about nuclear good, it can be uranium, plutonium, which can be used for nuclear technology. So a good or even a technology, nuclear technology itself, the technology itself is very rare. Not every country has this nuclear technology. So if it is a good or a technology, anything that has two different use case. For example, nuclear good or nuclear technology. You can make use of nuclear technology to generate electricity. So in India, we have many nuclear power plants in which we make use of this uranium and generate electricity. Now this is a civilian use. Why? Because you're using it for a very good purpose. All our citizens are going to get help from this particular use. It's a good use, nothing wrong in that. But the same nuclear technology, same nuclear good can be used for a military purpose. So you can make nuclear weapons also. And this is not a good thing. The international society would not like to use these things for the military cause. But this can be used. I'm saying this good can be used for two different things, and that's why we are calling it dual use good or dual use technology. Dual use, two different uses are there. To give you an example, I talked about the uranium or nuclear technology. You can talk about chlorine. See, chlorine we normally use in our pools, swimming pools, or to ensure that the water is purified. Now that's a normal civilian use, but you can make use of it to build chemical weapons. So we make use of chlorine gas to make chemical weapons. So this is a different military use. If we talk about vaccines, think about any vaccine, even the vaccine we made for COVID. Those vaccines are developed using some kind of a virus. Now see, the same virus can be used to make a vaccine which is very good for our civilian population. But the same virus can be used to make a biological warfare weapon, wherein you can infect people of a different country as part of your warfare tactic. So this is a dual use. You can talk about drones also. Nowadays we are making use of drones for photography, the marriage photography, or even in agriculture we are using it. But the same drones is also used by many terrorist organizations. So even for military surveillance, for security purpose, we can make use of drones. You think about satellites. We make use of satellites for the communication. We have GPS and all. Same satellite can be used for surveillance and intelligence gathering. So it's a military purpose. If you think about artificial intelligence, let's say the example of facial recognition software. In our mobile phones, we have this artificial intelligence based software in which we can use it to unlock the smartphone, which is a very good civilian use. But the same software is used for surveillance in China. Now, that is not a good thing. So overall, what we are trying to say, all these goods and technologies which have two different ways of use, military as well as civilian use, those are dual use goods and technologies, and the international community is concerned about its export. So international community has come up with some conventions, some treaties wherein they are trying to regulate it. Why? Because these things, if they get into the hands of either terrorists or most of the countries, the conflicts will increase, the military use will be more, so they want it to be controlled. Now we have some treaties. For example, the first treaty is 1970s Nuclear Non-Proliferation Treaty, in short NPT. Now this NPT does not only deal with all the dual use goods. It only talks about nuclear, that is nuclear technology and nuclear goods. This NPT came into picture in 1970, although India did not sign it because India felt that this is a discriminatory treaty. Because the treaty said that there are 5 countries who already have nuclear weapons. Only these countries will have nuclear weapons. No other country is going to get it. That means they stopped the proliferation. Proliferation means increase in number. So India said that no, this is very discriminatory and we will not sign this treaty altogether. Although in the treaty there were many other clauses that will go for disarmament, that in the world there will not be any nuclear weapon as such. But that was something they said we'll do on voluntary basis, we'll do in future. And they also said just make use of nuclear technology only for peaceful purpose. That means only generate electricity using nuclear energy. Don't make use of nuclear energy for making weapons. They said this for all the countries, but gave the exception to these 5 countries. These 5 countries include US, UK, Russia, China, France. These are those countries who are the permanent members of United Nations Security Council. India said we are not going to sign. We don't like this discriminatory treaty. But the treaty exists for one of the dual use good, that is nuclear. Another treaty in 1975, Nuclear Suppliers Group. India want to become part of this nuclear supplier group, but China is not allowing us to do that, saying that you are not part of NPT, so you can't become part of NSG also. Now this NSG is very important. If there is any country who is part of this particular group NSG, then that country can import or export nuclear related things. For example, a nuclear reactor, nuclear fuel, nuclear technology. The export can be done to this country. That's why India says that we want to become part of it. But we will not sign NPT because it is discriminatory. Clear? Then we have one group called Australia Group. This treaty was signed in 1985. Now, Australia Group is important. It does not talk about nuclear. It talks about chemical and biological weapons. So there are chemical and biological weapons which can be used for both uses, right? We talked about vaccines, similar things. For that, we have Australia Group. Then we have Missile Technology Control Regime, came in 1987. This specifically talked about missiles. It says that missiles which can be used to send some kind of nuclear weapon also, all those missiles should be controlled. And then we have Wassenaar Arrangement, came in 1996. It talks about conventional weapons, normal conventional weapons, for example artillery, so some kind of tank or anything, normal weapons. I'm trying to tell you all of these are examples of treaties which are trying to regulate some kind of dual use good or some kind of dual use technology. Clear? On the international flora, this is happening. As far as India is concerned, if we talk about India as a country, I said we are not part of these two, but we are part of these three: Australia Group, MTCR, and Wassenaar Arrangement. India is part of these three, not just part of these two. Clear? Please remember this fact. Now, India in itself, as a national government taking some actions, India has come up with a list. This list is called SCOMET list. SCOMET means special chemicals, organisms, materials, equipment, and technologies. This is the short form SCOMET. Indian government prepares this comet list. In this list, they add dual-use goods and technologies. And Government of India clearly says that we have a specific agency called Directorate General of Foreign Trade. It is their responsibility to ensure that if someone is exporting any material or any technology which is mentioned in this list, then they should get some kind of a license or they can be verified by this agency. So we have also tried to regulate dual use goods and technologies through this particular list. Clear? Very good. Now, the third topic. This is related to small modular reactors. Very important because right now Government of India is discussing to build small modular reactors, and they are saying we are going to make use of private sector. Now, please understand, whenever we are building any nuclear power plant, you must be aware of nuclear power plants. See, we have power plants where we generate electricity. We have thermal power plant in which we make use of coal. Using coal, we generate heat. That heat is used to heat up water. So there is water which will be heated up using coal. Coal burns and heat comes out, because of which water will boil, and that boiling water will lead to some kind of steam. Okay, and this steam will move ahead, and then there will be a device which will rotate. Okay, if the device rotates, then we can say that there will be generation of electricity. Okay, so this is your turbine. If using any method, if you are able to rotate turbine, then you can generate electricity from it. This is the speciality of this particular device. Now this is the normal process we use in our power plants. Now when it comes to nuclear energy, instead of making use of coal, we make use of a nuclear material. We make use of, let's say for example, uranium. Uranium is a nuclear material. Or we make use of plutonium. So using it, we will generate heat. That heat will again boil this water, then the steam will come out, and then the turbine will move or rotate and electricity will be generated. So the mechanism is more or less same in almost all the power plants. It's all about what you are using for it. Okay. Now earlier the nuclear power plants we had, they were traditionally very larger, and now we are talking about small modular reactors, very small kind of nuclear power plants, and that will be built making use of private sector. Earlier we did not allow private sector to become part of any kind of mechanism wherein we are developing this nuclear electricity or nuclear energy. Why? Because see, if nuclear material gets into the hand of a private individual, a businessman, or a terrorist, or any other person, they can create nuclear weapons that can lead to a big disaster. So government is very concerned. Government wants to ensure that this material does not go into the hands of private sector. But now government is saying we are going ahead with some reforms. We are coming up with a new module wherein we can ensure private sector also plays some key role. Okay. Now, for the basic understanding of nuclear energy, we need energy. Please understand what is energy. Energy is anything that will fuel us or that will provide us some kind of power. For example, if you're using bike, you need petrol. What petrol does? It burns. Once the petrol burns, some energy comes out, and that energy is giving power or providing fuel to this machine. That machine is working just because of this energy which is coming from petrol or diesel or anything. In case of any electrical device, let's say this smart board is working because there is some energy coming up over here. That energy is in the form of electricity. So we are saying our modern civilization requires some kind of energy source. Now this energy can come from multiple sources. One of the source could be your coal or any fossil fuel. For example, petrol, diesel, all these are fossil fuels. They are very limited. See, coal, there is a limitation to get the coal. Or you talk about the crude oil. There is a limit to which you can extract crude oil. At some point of time, this crude oil will be exhausted. We are still using it, one day it will exhaust. Now, this is one of these sources. But we felt that when we are using coal or crude oil or all of these sources, this is leading to some kind of pollution. This is leading to greenhouse gas emission. And because of all of this, we are observing the phenomena of global warming. So the world community came together saying that what we'll do is we will not now rely on these fossil fuel based energy sources, and we will transition towards some renewable sources. Renewable sources means those sources which have potential to renew itself. There is no limitation of using it. For example, if you think about solar power, you're getting energy from sun. Sun is not a limited source. You can gain energy even for next thousands and lakhs of years. So solar energy is there. Wind energy is there. Hydro energy is there. These are good examples of renewable energy. And good thing about them is that there will not be pollution just like these fossil fuel based energy sources. So these are good sources. So we want to transition from these fossil fuel or based or non-renewable sources to these renewable sources of energy. But there is a problem. First of all, we do not have an advanced kind of technology available to build these renewable sources. Second, they can be very costly for the time moment. If you ask Government of India to install all these renewable sources and remove all that coal and oil based things, then it's a costly thing. It's not easy to do it right now. It will take some more time. And secondly, it's not like they are completely pollution free. There can be instances wherein there can be little bit pollution. And most importantly, these sources are not completely reliable. Please see, if you're using solar panels, when there is light, then you can use solar panel. But let's say in the monsoon, there is no sunlight. Let's say it is possible, or there are some areas wherein the sunlight is very scarce, very low. Then can you rely on these solar panels completely for the electricity? No. So considering all these angles, we came to the conclusion that we need a different source also. That source is your nuclear energy. Now, the speciality of nuclear energy is that, first of all, when you generate electricity, it will be generated in a very large volume. Second thing, it is one of the cleanest source. It is very clean because you will not find any kind of pollution from this nuclear energy. Maximum byproduct you will get from a nuclear power plant will be water. So the point is, it is a very clean kind of a fuel. That's why we are making use of nuclear energy. Clear? Now, what is a nuclear energy? How are we getting it? The term nuclear comes from the word nucleus. So if you have heard about atoms, see, everything you see, any physical thing, that is made up of atoms. The smallest unit is atom. Even this pen is made up of atoms. Every atom will have its own nucleus. Let's say this is the atom, this is the nucleus. This is atom number 1 and this is atom number 2. This is the nucleus. Now, when there is a reaction wherein we are talking about a reaction taking place at this nucleus level, that is a nuclear reaction. And any such reaction, let's say we are combining these two nucleuses, then that nuclear reaction is so heavy that it generates immense amount of energy that we can't even imagine. You think about nuclear bomb, it is nothing but combining two different nucleuses. They combine, or maybe even you can split it. So there are two different kinds of nuclear reactions. One is called nuclear fission and another one is called nuclear fusion. Please understand in simple. If I have a nucleus and if I have another nucleus, if I combine them, that is mean fusion. You're fusing them together. That will generate energy, immense energy. Now here usually what happens is that a smaller or less heavy nucleus you take and then combine. Another mechanism is fission, as I said. Fission means you are splitting. You have a very big heavy atom, you are dividing this nucleus into two. So you made two different atoms with two different nucleus. You are splitting it. That is called fission. If I talk about our nuclear power plants that we have in India, they are making use of this same mechanism, nuclear fission. They are dividing one nucleus into multiple. Now these two will be divided into two. These two will be divided into two. This reaction will continuously go on. We call it a chain reaction. So the chain reaction will continue. It will not stop. It's not easy. That's why when you're building a nuclear power plant, there is a chance that this reaction will continue. Energy will keep on generating, and it may lead to a big blast. So what they try to do, the scientists try to do, they try to control this reaction. So a nuclear power plant is something where there is a reactor, a device called reactor, which ensures a chain reaction of nucleus which is controlled, which is not uncontrolled, which is controlled. And we generate a good amount of energy or electricity. Are you getting it? Good. Now, look at this data, a basic data you must know. Right now, India is very much dependent on the fossil fuels. The data says that more than 60% of our electricity is coming from coal-based power plants that we call as thermal power plants. So we are dependent on coal, and we are saying we have greenhouse gas emissions and all. That's why we want to shift to renewable sources, and that's why nuclear energy acts as a bridge. See, we want to use renewable energy, but for the transition period, we want nuclear energy to be there. It can ensure a stable supply for us. Clear? Now, this we have already understood, nuclear reactors and all. Now, when you are developing a nuclear power plant, we said that traditionally we had very large power plants. This kind of a nuclear reactor is there. Very large power plants are there. They are very costly also to build it. The infrastructure is very costly. Everything is very much complex. And here you used to generate electricity. Now government is saying, instead of building such large traditional power plants, why not make smaller ones, very small? This is what we are calling as small modular reactor. Now small modular reactor will be very small in size. It will be generating electricity up to 10 megawatt to 300 megawatt. So size is smaller, things will be relatively small. But there is some strategic importance of these small modular reactors. Please understand how it is going to be very important. First of all, these are very smaller in size. So you can build it very easily in very less time period. The cost will be very low, obviously. And most importantly, when you're building those large traditional power plants, you used to do it on the spot at the field. But if you want to build a smaller one, you don't need to build it there. You can have your factory, manufacturing factory in one place. You can make it over there and then transport that small modular reactor to any other part of the world. That means it is very easy to build also. So overall, it is highly flexible because of its modularity. Modularity means it is very small and it is very independent. So you can make it, you can use it in any part, any other parts. That is possible. Cost is very low, economically very viable. What happens is that if you ask an investor to put money in the nuclear power plant, you say that we want to build a nuclear power plant, sir, please provide us some money. Investor thinks that I want profit as soon as possible. I can't wait for a very long time period. So he will see that to build a traditional nuclear power plant, it requires 4 or 5 years. Once it is built, then it becomes operational, then I'll get some profit out of it. So the time period is very long, so I don't want to invest in it. But if you talk about small modular reactors, these smaller reactors, they can be built in very small time period. So here, even the investor will be interested in putting some money. Okay, and when we are making these SMRs, we are thinking about making use of private sector. So private sector can provide us designs, can help us build that infrastructure, can help us in the manufacturing part also. So overall, the idea is very good, very innovative. You must know about small modular reactors. Clear? Now the next article is related to submarine Arighaat. Recently, Indian Navy has commissioned submarine Arighaat officially. And this submarine is very important for India's nuclear triad. Now, to understand all these terms, we need to go for each and every term in detail. And this topic is important for prelims as well as mains. You should know INS Arihant, nuclear triad, and this submarine Arighaat. Now, first of all, what is a submarine? Now, you know that there are many things which military or navy or air force has to attack the enemies. One of them is submarine. Submarine is a vehicle, you can say, which is operating below the water, or you can say it remains underwater. Now, to remain underwater, it requires many things. So just like any other vehicle, it also needs some kind of a fuel, some kind of an engine. And when it is underwater, it has to stay there for a very long time period. Now these submarines, they look like this simply. They are operating underwater. Some officials will be there in it. There will be many weapons installed in it. You can even put nuclear missiles in the submarines. And it is very difficult for any other country or any of your enemy to track your submarine. Okay, because it is underwater, it is continuously going from one place to another, so nobody can easily track it. This is the speciality of any submarine. Now these submarines are of two types. One is diesel electric submarine and second is nuclear powered submarine. See, the difference lies in their engine and the fuel they require. There is one submarine which can work on diesel. So there will be a motor which will require diesel. Because of burning of diesel, it will get some energy, and using that energy, this submarine will work. Now it's very obvious for you to understand that if there is a submarine that you have sent, it is now underwater, running from Indian Ocean to Pacific Ocean and somewhere else. Now what will happen once this diesel, now there is a capacity of a fuel tank in which you can put this diesel. Once all of this diesel gets exhausted, once all of it is burnt, what will you do? That submarine will come out. It will come out of that. When it was underwater, it will come out and then refuel itself. So it will have to come back to our spaces. So without doing that thing, there is no other way this submarine can sustain there. That means when it comes to diesel electric submarine, it can remain underwater for a very limited time period, and after some time period it will have to come back on the surface. Okay, for the diesel obviously. Now we have second, nuclear powered submarine. The reason why we built nuclear powered submarine is because we have limited possibilities available with diesel electric submarine. We wanted that our submarine should remain underwater for a very long period. It should remain underwater continuously. But to remain continuously over there, they require continuous energy source. So they thought, instead of putting diesel over there, let's make the energy on the spot. So if you can generate electricity or generate energy on the spot in this submarine itself, that's a better option. So we decided we will build nuclear powered submarine. So I have told you about nuclear energy, how we generate nuclear energy in our nuclear power plants. Now similar kind of mechanism will be there in this submarine, although very smaller, but it will be there, wherein we will make use of nuclear materials like uranium or plutonium, and we will generate energy or electricity in the submarine itself. Now when you are generating, it's like earlier you had some other source. Here you are generating on your own. So energy supply will be there continuously. So this submarine can remain underwater for a very long time period. Okay, for very long period you can expect this will remain underwater. So it's a very good thing for us. Now every country wants that they should have nuclear powered submarine. So obviously even India wants to have it. So we have now commissioned INS Arighaat, and this is a nuclear powered submarine. This is second indigenous nuclear powered ballistic missile submarine. Now you should know each and every term. You should understand it. First we said it is nuclear powered. It's a submarine. It's nuclear powered. Third, it is second indigenous one. Which was the first one? Then it is INS Arihant. After INS Arihant, this is second one. Indigenous means we have developed on our own. We did not import it from any other country. So indigenous. And third, ballistic missile submarine. Now what do we mean by ballistic missile? So please understand, I said these submarines can have weapons also. That can have nuclear weapons also or normal weapons also. Now when I say weapons, specifically we talk about missiles. And these missiles are of two categories. One is called as cruise missile. Second one is called as ballistic missile. What is the basic difference? The basic difference could be understood in this manner. Let's say I want to attack from Rajasthan area to one of the areas of Pakistan and the distance is very short, let's say. In that case, what I will do is I'll make use of cruise missile. Now what cruise missile will do? It will start from a particular location and it will move ahead directly. It is very easy to use, a very good one when you want to go ahead with a precision and you have a distance which is very short. But let's assume you want to attack on a country which is at a very far distance. Let's say you want to attack on Beijing, which is at a very far location from India specifically. Now here you will not use cruise missile. Here you will use ballistic missile. Now why do we even call it a ballistic missile? How it actually works. Let's say you sent your missile from this location. You want to attack on this location and the distance is very far. Now here you will not directly send it like this. If you send it like this, that means it is a cruise missile. It is not ballistic. But ballistic missiles works in a different way. What you will do is you will send your missile in this manner over here. Whatever fuel you require to send your missile till this location, you will use it. Once it reaches here, your fuel is completely exhausted. You don't have any fuel. It can't go ahead. But because of gravity, what will happen? You have already sent here. Because of gravity, automatically it will continue its path like this. And here you will reach to your particular location where you want to attack. So that means you are only using fuel only for half of your path. And remaining path you are not using your fuel. Now this was not the case for the cruise missile. This is only case for this ballistic missiles, and this is the reason we can cover maximum distance. You see, only half of the distance you need fuel. Remaining half it will cover automatically. So this, when you are looking at this particular path, this path itself is called as ballistic path, and that's why the missile is also named as ballistic missile. Clear? So now let's come back. If we talk about INS Arighaat, what is it? It is a submarine. Second, it is a nuclear powered submarine. And third, it is a ballistic missile submarine. That means it can attack using ballistic missiles. And it is second indigenous in line after INS Arihant. Now please understand, why do we need such kind of nuclear submarine, specifically nuclear powered submarine? You see, we as a country have nuclear weapons. But do you think just having nuclear weapons will make you secure? Let's assume both Pakistan and China attack India at the same moment with so many missiles. Let's say 200, 300, 5,000 missiles they used at one moment. And they attack on all the locations where India has reserved its nuclear weapons. So they will attack on the land. Maybe our air force is having some kind of nuclear weapons. They will attack on the new air force also. So if such heavy attack is done in which entire land of India is destroyed, all the areas where our nuclear weapons are stored, everything is destroyed. What will you do in that case? If you look at India, the policy of India, what government of India says, we will not attack with nuclear weapons with first strike. That means we say that we have a policy in which we will not attack first. If someone attacks us with nuclear weapons, only in that case we will retaliate, we will attack back. But think about the situation wherein they have attacked in such a manner that you cannot even use your nuclear weapons. So in that case, what country like India needs is a nuclear triad. What is nuclear triad? Nuclear triad means you have the capability to attack using nuclear weapons in three different manners. One is through your land using your army, another one is using your air force, and another one is using your navy, or to be specific, using your submarines. Now, please understand. We said if China and Pakistan attack, they can attack on all the missiles we have on our land or with our air force. But there is one problem with the submarines. We said that it is very difficult to track submarines. You cannot even find these submarines. They are continuously underwater, moving away, moving from Indian Ocean to Pacific to any other ocean. So if China or Pakistan cannot even find these submarines, do you think they can attack them? No. And if you have a submarine which is nuclear powered, that means it can remain underwater for a very long time period. It doesn't even need to come on the surface just like diesel powered. So this is a safer option. Here you have also put your nuclear weapons. Now China and Pakistan will think again and again before attacking India, because the submarines can attack them anytime. And to build this submarine, if you have built your nuclear weapons and put it in all these three areas, then we can say you have developed a triad, nuclear triad. This nuclear triad makes you completely safe, and you can rest assured that even if any country attacks us, we can retaliate back. Even if entire India is destroyed, still these submarines can attack that country, so that retaliation is possible. And to bring all of this, Indian government started working on a project. That project is Advanced Technology Vessel Project. Please, this name is important. Advanced Technology Vessel Project. Under this project, Government of India started inducting some submarines, nuclear powered submarines. The first submarine was INS Arighaat, brought in 2016. Second one is INS Arighaat, which we are right now discussing. And third one, which is the upcoming one, is INS Aridhaman. So these three are part of this project. This project was brought in to complete our nuclear triad, in which we were bringing submarines, specifically nuclear powered submarines. This is the complete picture. Clear? Okay. Now, moving ahead with the last topic for science and technology. This topic is related to what is helium and why is it used in our rockets or spacecrafts. What recently happened is that Sunita Williams and one more space astronaut, they went to International Space Station. After spending some time, they wanted to come back, but they got to know that the spacecraft through which they came to International Space Station, they are not able to go back because the spacecraft is not working properly. And after some time, they got to know that there is a leakage of helium gas in this spacecraft. Now we want to know what is this helium and why are we even using it in the spacecraft from exam perspective. So for prelims, this becomes important. Now, what is helium? You must have seen the periodic table. If you look at it again, you'll see helium is mentioned in this group 18 number or group 0 number, that particular column. And this group 0 is very famous because it is named as a list of noble gas. Noble means in the periodic table, whatever is mentioned, most of the things are able to interact with other molecules or other substances. For example, there is carbon. For example, there is oxygen. Carbon and oxygen come together to form carbon dioxide or carbon monoxide. So they react. They have some kind of reaction with some other substances. But when it comes to group 18, whatever gases are mentioned over there in this group, they do not interact with any other substance or any other grouping, and this makes them noble gas. So if I talk about helium, helium is also a noble gas. Its atomic number is 2. It is one of the most lightest substance or one of the most lightest gas we have ever seen. You see, number one is your hydrogen and atomic number two is your helium. Both of these gases are present in the universe in a very abundant form. They are available in very much abundance. And when it comes to helium, it is second lightest, we can say. Although it is abundant in the universe, when it comes to earth, it is not that abundant. On the earth or the surface of the earth or atmosphere, you will not find much helium as such. When we extract our natural gas, there we find some part of helium. So it should be very clear for you that in the universe, helium is available in abundant way, but when it comes to earth, it is not available. Rather, it is very, very rare. Clear? Now, as far as rockets are concerned, as far as these spacecrafts are concerned, why are we using helium over there? See, spacecrafts have a similar kind of system when it comes to traveling. So just like our bikes have a fuel tank, have an engine, and from fuel tank, some fuel will go to that engine. That fuel will burn. After burning, some energy will come out, and because of that energy, that engine will work and the bike will move ahead. Now, similar kind of mechanism is available in the spacecraft also. But in spacecraft, you will not have just one engine, you will have multiple engines. And when you combine all those engines, we call it propulsion system. Now, here also similar thing happens wherein there is a fuel tank. From the fuel tank, fuel will come out. But what happens is that in the space, you have to ensure that the fuel tank has the same and stable pressure. Now, when you take some fuel out of it, let's say this is the fuel tank, and let's say there is 100% fuel over here. If you bring 20% fuel out, so 20% space will be there. So, there is a possibility that the pressure inside will become unstable. It will not remain the same. And this is not good for the spacecraft. When you are moving in the space, you need a stable pressure in the fuel tank. So, what we do is we put helium over here. So whenever we are taking any fuel out of it, the remaining space will be filled with helium gas. And because helium gas is very lightweight, it remains there and it maintains a good pressure. So the pressure will be very much stable and the spacecraft can work in a very nice manner. Now, good thing about helium is that it is an inert gas, inert or noble gas. What we said about this gas is that it will not react with any other gas or any other molecule. So what we wanted in space is that if we use any other thing, let's say if you use oxygen or any other thing, there is a chance that it will react with any other substance or any other fuel and it could burn, it could explode. But when it comes to helium, helium will not explode because it will not even react with any other thing. So it is one of the safer options to use in a spacecraft. So first thing I said, it will maintain pressure in the fuel tank. Second, I said it is an inert gas, so it is very safe to use because it will not react. Third thing is its application in the cryogenic form. Now, whenever we use this word called cryogenic, cryogenic simply means very, very low temperature. Cryogenic, we use this word to show temperature. Cryogenic temperature means very low temperature. Now you may think about very low temperature as below 0 degree. No, you can think about this temperature even below 0 degree, rather it is minus 150 degrees Celsius. So think about it. When you go into space, there will be this kind of temperature. Maybe even below minus 150 degree you will find in the space. So when you are using any fuel or anything, you have to ensure that it should remain resistant, it should work even in minus 150 degrees Celsius temperature. And this temperature is called as cryogenic temperature. Let's say if you are using petrol also, you can't use the same petrol in this temperature because it will become solid. So you need something that can remain liquid or gas and not become solid even in this temperature range. And if there is a substance of this quality, then it is having a cryogenic application. Now look at helium. In the normal room temperature, helium is in a gaseous form. If you want to make it liquid, you have to even reduce the temperature. So we are saying helium is a good option. We can use helium in that temperature, in that cryogenic temperature also. Clear? So these are the three reasons why rockets or spacecrafts would need helium. Okay. Now moving ahead. Why helium is prone to leaks? We said that recent incident in which this helium has got leaked from the spacecraft of Sunita Williams. So why is it that it is prone to leakage? Again and again we see some incidents where helium gets leaked. One reason is its smaller atomic size and smaller molecular weight. So we said that the size of the atom is very small. We said that the atomic number of helium is just 2. It's a very small atom. Its weight is also very less. So what happens is that if in your spacecraft there is some kind of crack, some kind of damage, some kind of imperfection or fault, from that fault line this gas will leak out. So because it is very small and very low weight, it can escape from these tanks or any kinds of systems. And this makes it prone to leakage every time. So this is a problem with it. And what we can do is we have to fix it. Either the governments of all the countries, they will have to come together, the agencies will have to come together and find a solution in terms of an alternative. Either we need to use something other than helium, or we have to make our systems in such a fashion that there will not be any kind of leakage of helium in future. So the system should be almost perfect. Okay. And right now, as far as Sunita Williams is concerned, she can come back to earth only when this helium issue is resolved. Okay. Thank you so much.